Welcome to Lesson 40. In this lesson, you will learn to calculate moles given the number of grams, and to calculate grams given the number of moles. Make sure you have a Regents Chemistry reference table and calculator. Let's get started. So a mole is many things. A mole is a counting unit in chemistry that is also equal to the gram formula mass of any substance. For gases at STP, it is equal to the volume of 22.4 liters, regardless of formula. And a mole, again, is a counting unit of 6.02 times 10 to the 23 particles.
The first thing to remember is that a mole is a foundation of chemistry. Here are two practice Regents questions. When we see the word mole, we often freak out, as moles can be unpredictable furry animals, or nasty-looking hairy growths on our skin. But a mole in chemistry is everything. The mole has always been here. So let's look at these problems and see that if we remove the mole, we can still answer the question. The first question asks, what are the total number of moles of oxygen in 1 mole of dinitrogen trioxide? If you remove the word mole, you can still answer the question. Did you get 3? Now you try the next question. Here we're looking for the total number of moles of atoms present in 1 mole of calcium phosphate. Just count up all the different atoms. Don't forget to distribute the 2 to the phosphorus and the oxygen.
A lot of times when we see the word mole in a chemistry problem, we really freak out thinking that maybe it's this furry rodent, but really a mole represents an amount that is always equal to 6.02 times 10 to the 23 particles. But a mole is the gram formula mass of any substance, as it is based on 12 grams of carbon-12.
Every 1 mole, or 6.02 times 10 to the 23 copper atoms, you will have a mass of 63.5 grams, while when you have 1 mole of oxygen atoms, you have a mass of approximately 16 grams. Here is a diagram of 1 mole of very different elements from the periodic table. So you can see that elements have very different masses and very different sizes. Notice how the mole of copper takes up much less space than the mole of sulfur. But what we do know is when we have a mole, all of these containers contain 6.02 times 10 to the 23 particles. So all of these elements have very different masses, volumes, and therefore densities, but they have the same number of particles.
In order to convert between moles and grams, we are going to use the equation found on reference table T, the back of your reference table. The steps for converting grams to moles are to calculate the gram formula mass of a compound, rounding masses from your periodic table to the 10th place, and plug in the given value and the gram formula mass into the mole calculation formula to solve for the number of moles. So let's work through this sample problem. Or if we're asked to find the number of moles of potassium chloride in 148 grams, let's see how we're going to apply the equation from reference table T. So by now you should be able to calculate moles given the number of grams. When given moles and you need to solve for grams, you're going to use the same formula. But when using this formula, you're going to have to clear the fractions. So in this question, what is the mass of 4.5 moles of potassium hydroxide? The first step is still find the gram formula mass of potassium hydroxide. And now we'll substitute into the formula on reference table T. So now we need to clear the fractions. That's easily done by turning the number 4.5 into a fraction by dividing by 1. Let's look at this other example. What is the mass of 0.50 moles of calcium sulfate? Again, what is the mass of 0.50 moles of copper sulfate? Step number 1, find the gram formula mass of copper sulfate. So we have 1 copper, 1 sulfur, and 4 oxygens. Now we're going to substitute in the equation from reference table T, mole calculations. Since we have a fraction on the right, we can turn the left into a fraction by dividing by 1. Then we clear the fraction. So by now, you should be able to calculate grams given the number of moles.
The idea of a mole was derived from Avogadro's principle, which states equal volumes of gas at the same temperature and pressure will always have the same number of particles. This is regardless of formula. We know that formula affects mass. Let's look at this Regents question. In this Regents question, we have 2 liters of methane gas and 2 liters of oxygen gas, and we were asked to find what is the same in both flasks at STP. We know it cannot be the number of atoms because methane's formula has 5 atoms, while oxygen's formula has 2 atoms. We also know the mass cannot be the same because methane has a carbon which weighs 12 grams and 4 hydrogens which weigh 1 gram each, while oxygen has 2 atoms that weigh 16 grams each. Since the mass cannot be the same and the volumes are the same, the density cannot be the same. So here, since these have the same volume at identical temperatures and pressures, they must have the same number of particles. Can you use Avogadro's hypothesis to solve this Regents question? Hopefully you can.
This concludes lesson number 40. Make sure you've taken good notes. We will check them in class. Write down any questions you have and bring them with your notes. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack so you are prepared for class. I'll see you soon.